Chapter 3, Sections 1 and 2. After you read the objectives, you can go ahead and do problem number 1. Graphing the following inequality. So now as you see, you have the graph here below. So in order to get that graph, let us use our intercept method to graph this equation. So for x plus 2y is less than or equal to 8. So I'm going to use the intercept method here, which means I'm going to let x is equal to 0, and I'm going to solve for y, and then I'm going to let y equal to 0 and solve for x. So 4 times 0 plus 2y is equal to 8. I'm just going to put an equal sign here. So this is gone. So divide both sides by 2. I have y is equal to 4. So this is the point. 0, 4 is right here. That's your y-intercept. So that's your first point. Now let's let y equal to 0 and solve for x. And that will be your x-intercept. So 4x plus 2y is equal to 8. So let's substitute 0 into the y. And again, that's gone. So you have 4x is equal to 8. So x is equal to 2. So here we have 2, 0, and that is our x-intercept. So we have 0, 4, 2, 0, and you're going to draw a solid line. Solid line because you have the underscore. It's less than or equal to. So when you have the underscore, you're going to use a solid line. And now let's use the test point to do the shading. So let's determine whether to shade above or below. So let's use a test point of 0, 0, which is a point not on the line. And I'm going to plug it into the x and to the y. So again, this is 0 is less than or equal to 8. So 4 times 0 is 0. 2 times 0 is 0. So is 0 less than or equal to 8? Yes, it is. It's true. So I'm shading toward the 0, 0. So the 0, 0 is shaded. And that's how I would graph this inequality. Moving on to number 2. Here I have a system of inequalities, and I want to state the feasible region if it's bounded or unbounded and determine the corner points. So here let's look at the first equation. 6x minus 2y is less than or equal to 12, and I'm going to do the same thing. I'm going to let x equal 0 and solve for y, and then I'm going to let y equal 0 and solve for x. So 6 times 0 minus 2y is equal to 12. Again, that's gone. So divide by negative 2. So y is equal to negative 6. So again, that's not on the graph, so we don't really need that negative 6 because you have x is greater than or equal to 0 and y is greater than or equal to 0. So you're just looking at x is greater than 0 and y is greater than 0. So we're not going to plot that negative 6, but let's let y equal to 0. We can plot our x-intercept. So we have 6x minus 2y is equal to 12. So 6x minus, now we let y is equal to 0. So that's gone. So 6x is equal to 12. X is equal to 2. So here we have x is equal to 2. And we draw a solid line again because it is less than or equal to. And again, let's use a test point. We can use 0, 0 again. So 6 times 0 minus 2 times 0 is less than or equal to 12. So is 0 less than or equal to 12? That is true. So we're going to shade towards the 0, 0. So towards the 0, 0 is less than to the left. Now let's do the same thing for the second line. We have 3x plus y is equal to 9. So let's let x equal 0. So we have 3 times 0 plus y is equal to 9. So y is equal to 9, and that's this point right here. y is equal to 9, and x is equal to 0. That's your y-intercept. Now let's solve for the x-intercept, and that is letting y equal to 0. So we have 3x plus 0 is equal to 9. 3x is equal to 9. Therefore, x is equal to 3. I'm sorry. 9 divided by 3 is 3. So our x-intercept is 3. And here we have 3, 0, and 0, 9. And again, we're drawing a solid line. Now let's shade that region. And we can plug in 0 for x and 0 for y. So 3 times 0 plus 0 is less than or equal to 9. So is 0 less than or equal to 9? That is true. So we're shading below. So shading below this line. So our feasible region is this. So now the corner points, we have one corner point, another point of intersection, and the other x-intercept. So these corners bound that feasible region, and again, the area is bounded. The area is bounded. And our corner points are, we determine this one to be 0, 0. So, and we have 0, 9. So 0, 9, 0, 0. We have 2, 0. That's this point right here, 2, 0. Now solving the point of intersection. To solve that point of intersection, I will use the substitution method. So using the substitution method, I will rewrite the second equation. So I'm going to rewrite the second equation as y is equal to negative 3x plus 9. And I'm going to substitute that second equation into the first equation. So I will do that right here below. So I have 6x minus 2 times y, and the y is negative 3x plus 9 is equal to 12. So 6x plus 6x minus 18 is equal to 12. Now combining like terms, the 6 and the 6 is the 12x. Adding 18 to the other side, 18 plus 12 is 30. Divide by 12. X is equal to 2.5. And once I get the 2.5, I want to substitute it into one of the equations, and I'll substitute it into the second equation. So substituting 2.5 into the x, I have 3 times 2.5 plus y equals 9. 2.5 times 3 is 7.5. 9 minus 7.5 is 1.5. And that is my other corner point. So x is 2.5 and y is 1.5. And these are my 4 corner points. And this completes the first part of section 3.1 and 3.2.